Ever find yourself glued to the window, mesmerized by a thunderstorm? You know, when the sky turns that dramatic gray and there's just electricity in the air?
Oh, absolutely.
Well, today we're diving deep into the science behind these captivating storms, those meteorological marvels. We've got some fascinating snippets from the Wikipedia article on thunderstorms.
Yeah, thunderstorms.
And let me tell you, there's more to these storms than meets the eye.
It's true, so much. It's easy to underestimate the sheer energy packed into a thunderstorm.
For sure.
Yeah.
So what are we talking about here? Like, how much energy are we talking about?
Did you know a single thunderstorm can unleash energy comparable to a small atomic bomb?
Wait, seriously?
Yeah.
That's mind-blowing. I always just thought of them as loud, dramatic rain showers.
Oh, it's far more intricate than that. That energy release is a testament to the complex interplay of heat, moisture, and atmospheric forces.
For sure.
It all begins, as you might expect, with warm, moist air rising.
Right, like a hot air balloon. Warmer air is less dense, so it floats upward.
Exactly, yeah.
But what happens after that?
You got it. That rising air full of water vapor starts to cool as it climbs higher into the atmosphere, and this cooling causes the water vapor to condense.
Okay.
Think about those little water droplets forming on a cold glass on a humid day. Same principle, but on a massive scale.
So the air rises, cools, it forms clouds.
Right.
But that doesn't explain the immense power of a thunderstorm, does it?
Exactly. The real kicker is what happens during condensation. It's not just about the water changing states, it's about the heat being released in the process. This is called latent heat, and it's like adding fuel to the fire.
Okay, I'm intrigued. So how does this latent heat amplify things?
Imagine this. As the water vapor condenses, it releases heat into the surrounding air. This warming makes the air even less dense, causing it to rise even faster. It creates a powerful updraft, like a giant vacuum sucking more warm, moist air into the storm.
Wow, so it's a self-perpetuating cycle.
Yes.
The more condensation, the more heat, the stronger the updraft, the more warm air gets pulled in. Things escalate quickly.
You're getting it. This is how those towering cumulonimbus clouds, the giants we associate with thunderstorms, are born. They can climb miles high, sometimes even reaching the tropopause.
The what applause?
The tropopause.
Okay.
It's the boundary between the troposphere, where weather happens, and the stratosphere.
Gotcha.
When these powerful storm clouds hit this ceiling, their tops spread out, creating that iconic anvil shape.
Okay.
Scientifically, it's called cumulonimbus incanus.
Cumulonimbus incanus.
A fun fact to impress your friends with.
I'm adding that to my vocabulary. But let's talk about the other stuff that forms in these storms, like hail. It can be pretty menacing, especially if you're caught in a hailstorm.
Hail formation is fascinating. These powerful updrafts we've been talking about act like a giant chaotic elevator, flinging water droplets up and down through freezing temperatures.
Okay, so I'm picturing a raindrop on a roller coaster ride through an icebox.
Each time the droplet is tossed upwards, it freezes a little more, gathering more and more layers of ice. Eventually, these hailstones become too heavy for even the strongest updraft to keep aloft, and they plummet to the ground.
Wow. And sometimes thunderstorms have that eerie greenish hue. What's that all about?
That's a great observation. It's often linked to hail. While the science is still debated, one theory suggests the green light is scattered more effectively by large hailstones within the cloud.
So that greenish tint could be Mother Nature's way of hinting at some serious hail on the way. That's incredible.
Precisely. But remember, thunderstorms are incredibly dynamic and varied. They're not a one-size-fits-all weather event.
It's like a whole taxonomy of storms out there.
It really is, yeah.
So let's break it down. What kind of thunderstorm variety pack are we working with here?
Well, we have your everyday single-cell thunderstorms. These are your quick isolated showers, the ones that roll in with a brief rumble and then disappear as quickly as they came.
The flash in the pan of the thunderstorm world.
Exactly.
What causes those?
They form in areas with low wind shear. So that means the wind speed and direction don't change dramatically with height.
Okay.
Without that wind variation, the storm's life cycle is short, usually just 20 to 30 minutes.
Okay, so short-lived and usually not too intense. But things can get more interesting, right?
Yeah.
What happens when we crank up the complexity?
That's when we encounter multi-cell storms. Imagine clusters or lines of individual thunderstorm cells all working together.
Okay, so instead of one quick downpour, you've got a whole team of them.
Exactly. These multi-cell storms form in environments with greater wind shear, which helps to fuel them for longer periods, sometimes for hours on end.
And I'm guessing that means a greater chance of heavy rain, hail, maybe even a tornado warning?
You're spot on. Multi-cell storms can pack a much bigger punch than their single-cell counterparts. They're the ones that often bring the moderate-sized hail, flash floods, and even the occasional weak tornado.
Wow, it's amazing how a change in wind conditions can make such a difference in a storm's personality. So if a single cell is a quick shower and a multi-cell is a stormy afternoon, what's the thunderstorm equivalent of a full-blown meteorological masterpiece?
Now you're talking about squall lines.
Hmm.
These are the heavy hitters, those impressive lines of thunderstorms that can stretch for hundreds of miles across the horizon.
I've seen those on weather maps. They look like a wall of storms just marching across the country.
They're often associated with cold fronts, and let me tell you, they bring the drama.
Yeah.
Heavy precipitation, strong, straight-line winds.
Wait, straight line winds, are those as dangerous as they sound?
Absolutely.
Really?
These winds can reach speeds of over 100 miles per hour, easily uprooting trees, toppling power lines, causing serious structural damage.
Oh, wow.
They can be just as destructive as a tornado in some cases.
It's incredible how much power these storms can pack. We've covered the single cell, the multi-cell, the squall line, but there's one more category, right?
Right.
The one that gets storm chasers really excited.
Yes.
Tell me about supercells.
Supercells.
Yeah.
They're the rock stars of the thunderstorm world, the most powerful and longest-lasting storms on Earth. We're talking intense, rotating updrafts called mesocyclones that can reach heights of up to 60,000 feet.
60,000 feet. That's practically piercing the stratosphere. No wonder they produce the most destructive tornadoes and the largest hail.
And here's a sobering fact. 90% of supercells cause severe weather. They're a force to be reckoned with.
90%. So we're talking lightning, large hail, powerful winds, flash floods, and tornadoes. I think it's easy to forget how dangerous thunderstorms can actually be.
Yeah.
It's not just about enjoying the light show from a safe distance.
You're absolutely right. It's vital to respect the raw power of these storms. Maybe we should spend some time unpacking those hazards in more detail because knowledge is power when it comes to staying safe.
Okay, let's talk hazards.
Okay.
We all know lightning is dangerous, but it's more than just the initial strike, right?
Exactly. Lightning is a major culprit behind wildfires, especially in dry conditions.
Right.
It's like nature's own incendiary device.
Oh.
There's even a specific term for thunderstorms with lots of lightning but minimal rain. Dry thunderstorms.
Okay.
Those are the ones that really raise the alarm for wildfire risk.
So no rain to dampen things down, just a lightning strike, igniting dry brush, and boom, wildfire.
Exactly.
And then we have hail.
Yes.
I read about Hail Alley in the U.S. where hailstorms are incredibly common.
Yeah,
It's a good thing I don't live in Cheyenne, Wyoming. Isn't that one of the most hail-prone cities?
it is. That region where northeastern Colorado, southeastern Wyoming, and southwestern Nebraska collide
Right.
sees a remarkable amount of hail.
Yeah.
And speaking of remarkable, remember that hailstorm in Aurora, Nebraska back in 2003?
Mm-hmm.
It produced the largest hailstone ever recorded in the U.S.
Wait, seriously, how big are we talking? Like golf ball size, softball?
Think bigger.
Oh my gosh.
This monster was 8 inches in diameter,
8 inches.
almost the size of a volleyball,
Wow.
and weighed nearly 2 pounds.
2 pounds. That's more like a falling cannonball than a hailstone. It's incredible how these storms can create something so destructive from something as simple as frozen water.
I know, right?
Okay, we've covered fire from the sky and ice bombs, but we can't forget about flash floods.
Yeah.
Those always seem to catch people off guard.
And they can turn deadly in an instant.
Right.
Flash floods are a bit of a deceptive danger.
Yeah.
People think it's just water,
Right.
but that water moves with incredible force, especially in large quantities.
And certain environments are more susceptible, right? Like urban areas with lots of concrete or arid regions where the ground doesn't absorb water easily.
You've got it.
Okay.
In those situations, the water has nowhere to go but to accumulate and surge, turning streaks into rivers and dry creek beds into raging torrents.
Yeah.
That's a recipe for disaster.
It's amazing how these different elements of a thunderstorm can create such a cascade of hazards.
Yeah.
Okay, before we move on to safety tips,
Okay.
there's one more thread I wanted to ask you about. Downbursts.
Okay.
Those sound terrifying.
They are powerful, that's for sure.
Yeah.
Imagine a column of air rushing downwards from the heart of the thunderstorm.
Okay.
When it hits the ground, it spreads out violently, creating incredibly strong straight-line winds.
So it's like a sudden microburst of air slamming into the ground.
Exactly.
Yeah.
And those winds can be as strong as a tornado, causing widespread damage.
Wow.
People often mistake downbursts for tornadoes because the destruction can be very similar.
That's wild. And to think there's even a phenomenon called thunderstorm asthma, which I'd never even heard of before.
Right.
Yeah.
That one's a bit of a hidden danger.
Yeah.
Basically, during a thunderstorm, especially one with strong downdrafts,
Okay.
pollen grains in the air can rupture when they get hit with all that rain.
So imagine a pollen grain getting pummeled by a raindrop.
Yeah.
What happens?
It explodes. Well, maybe explodes a bit dramatic, but
Right.
these pollen grains burst into tiny fragments,
Okay.
small enough to get swept up into the storm clouds and then carried for miles by the wind.
Like a pollen dispersal bomb going off.
And here's the kicker. Those tiny fragments are so small they can bypass our normal defenses like nose hairs.
Oh,
They make a beeline for our lungs.
Oh.
For people with asthma or allergies, that can trigger severe attacks.
Wow. So it's a perfect storm for anyone sensitive to pollen.
It is.
Thunderstorms are clearly not something to be trifled with.
No.
Speaking of which, let's shift gears and talk about staying safe during these intense weather events.
Okay, sounds good.
A good starting point is understanding that any thunderstorm, regardless of its size or type, has the potential to turn dangerous.
Absolutely.
Don't let a seemingly mild storm lull you into a false sense of security.
Right.
So no matter what, when thunder roars, go indoors.
Exactly. Find a sturdy building or a hardtop vehicle and stay put until the storm passes.
Okay.
And remember, being inside doesn't make you invincible.
Right.
Stay away from windows, plumbing, and anything that conducts electricity.
And ditch the idea of getting that epic lightning photo for Instagram.
Yeah.
No selfie is worth risking your life for.
Couldn't agree more.
And here's a myth buster. Lightning never strikes twice in the same place is totally false.
It is.
Okay.
Lightning loves tall, isolated objects.
Right.
And it's perfectly happy to strike them multiple times if given the chance.
So no sheltering under the lone tree during a thunderstorm?
Definitely not. And while you're inside, unplug electronics and avoid using corded phones.
Okay.
Lightning can travel through electrical and plumbing systems.
Right.
And the last thing you want is for your electronics to get fried.
Of course.
Or, worse, for you to become a lightning conductor.
Okay. That's good to know. I'll admit I've been known to take a shower during a thunderstorm.
Really?
I'm guessing that's not the smartest move.
You're braver than I am. It's best to avoid any contact with water during a thunderstorm, just to be on the safe side.
Noted. Okay, before we wrap up our thunderstorm deep dive, there's one last thing I wanted to ask about.
Okay.
I read that we've observed lightning on other planets, which is just mind-blowing.
It is incredible.
What can you tell me about that?
Isn't that incredible? We've seen lightning on gas giants like Jupiter and Saturn.
Wow.
Now, the exact mechanisms might be a bit different, but the fundamental ingredients, energy, moisture, and atmosphere, are all there.
Yeah.
Just imagine a thunderstorm raging across the swirling clouds of Jupiter.
Wow, that's an image I won't soon forget. I have to say, I'm looking at thunderstorms in a whole new light now.
Yeah, me too.
It's one thing to appreciate their beauty from afar, but understanding the science, the sheer power, and the potential hazards, it really gives you a new level of respect for these meteorological marvels.
I couldn't agree more. Knowledge is power, especially when it comes to weather.
Well said. A huge thank you to our expert for illuminating the world of thunderstorms for us today.
Oh, it was my pleasure.
For all of you listeners, remember, the next time you hear that distant rumble or see a flash of lightning across the sky, think about the complex forces at play, the potential dangers, and most importantly, stay safe out there.